Okay, so now we're going to find the nth partial sum, which I'm denoting this way using summation notation. It's the nth partial sum of the first n terms of a geometric sequence. So as you can see, that's the general term. A1 times r to the I minus 1. Um, but each individual term is going to have its own value for I, each of the summands. So of the first n terms of a geometric sequence with first term a1. So a1 is the first term. That's the first term. Okay. And the common ratio is r. So r is the common ratio. So that sum, the sum from I equals 1 to n of those nth terms of geometric sequence, when you add them all up, you just get this expression right here. This expression will give you that sum. So this expression says it's just the first term multiplied by 1 minus the common ratio to the power of n over 1 minus the common ratio. So let's go ahead and take a look at dealing with that. So it says find the sum of the first 9 terms of this geometric sequence. So the things that I need to know to find this sum, to find this sum from I equals 1 to 9, the first 9 terms of, well, let's see, it's a1 times r to the I minus 1. So a1 is obviously negative 2, so that's negative 2. But then we need to know the common ratio. The common ratio is going to be raised to the power of I minus 1. In this case, the common ratio, well, it's the ratio of 6 and negative 2, the ratio of negative 18 and 6, and the ratio of 54 and negative 18, which is negative 3. So the common ratio is negative 3. So then this factor is just going to be negative 3 to the power of I minus 1. So this is negative 3 to the power of I minus 1. So if you were to add up all those 9 terms that are described by that summation, what this thing says is that you just get this expression. You wouldn't actually have to add all 9 terms. You would just get a1. a1 is negative 2 multiplied by 1 minus r to the nth power, which would be 1 minus r is negative 3, and that's to the power of n, where n is the number 9. So that's n, right? And that's all divided by 1 minus r. So that's divided by 1 minus negative 3. So in working this out, we get this is equal to negative 2. And then when you work out the inside of that parenthesis, let me see, negative 3 to the 9th power is 19,683. If you take that away from 1, you get 19,684. And then we're going to multiply that by negative 2 and divide that by 1 plus negative 3, which is 4. So this is negative 1/2 of whatever number this is right here. Negative 1/2 of this number. So the product of negative 2, okay, let's see. And then we divide this by 2. And the answer I get is a negative 9,842. This is just the final answer. Negative 9,842. So that means the sum of the first n terms, which would be negative 2 plus 6 minus 18 plus 54 plus dot 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 plus all the way up to the ninth term of the sequence, all the way up to the ninth term, a9, which I'm not sure what the ninth term is. We didn't have to find it. If you add up all those things, you'll get negative 9,842. So that's what the summation is. That's the sum of the first 9 terms. Here's a second example. A job pays $50,000 for the first year with an annual raise of 5% per year beginning in the second year. What is the sum of the yearly salaries if a person retires after retires from this job after 30 years? All right, so that's actually also pretty straightforward. We have the first year, there's a $50,000 salary. The next year, the salary goes up by 5%. So you're going to take the 50,000 and multiply it by 1.05 to send it up by 5%. That's 105% of the previous year. Then we're going to add to that 50, and then the previous year's salary was 50,000 times 1.05. We're going to multiply by 1.05 again to get the third year's salary. So this is going to be 1.05 squared. And of course, you're going to keep adding those, that, all the way out to the 30th year. Well, in the 30th year, you're going to have that 50,000, and it's going to be times 1.05, and you're going to be raising to the 29th power, because for the first year there was no 1.05. For the second year there was only one power, the first power of 1.05. Then for the third year it was the second power. So the power is always one less than the year. That's the formula. A1 times r to the n minus 1 is the nth term, right? Okay, so if you add up all those terms, here's what you would get based on this formula right here. Based on this formula. The formula says what we should get is A1 times 1 minus r to the nth, which in this case is 30. Oops, let's just write n before we bring everything in, right? And that's divided by 1 minus r. So in this case, A1 is obviously 50,000. And then it's 1 minus r. The common ratio, if you divide consecutive terms, you're going to get 1.05. 1.05. And this is to the power of n, which is 30. 30 years on the job. You close that up. You divide that by 1 minus 1.05. And let's see what we get here. So, okay, so rounding this to the nearest dollar amount, I get that the amount of money is $3,321,942 over a 30-year career. All right, so $50,000 a year, 5% raises for 30 years. In the life of that job, you'll make a bit more than $3 million.